Hello YouTube! Welcome to my channel. It's been a minute since my last video, so my last project took a while, and it became a bit of an obsession. I built my own 3D printer from scratch, my own design and plans. It's been a lot of fun. Today I'll show you what I did, and why you might want to do something like this. First, let's talk about what this isn't. Building your own printer from scratch isn't cheaper than buying one or buying a kit. I tried. I went as cheap as possible with my design, but there's no competing with the low-end box prices now. My system came in just a tad under $330 for the first working prototype, and I quit tracking from there. Second, it won't necessarily work better than a cheap off-the-shelf printer. Not at first, at least. After all, this is an Alpha 1, the first prototype. Those retail printers, they've been tested and refined for years. Which leads us to why you might want to build one. After all, if it isn't cheaper or better, why would you do it? Well, like most DIY projects, it's to learn. It's for the experience. In this scenario, it really is more about the journey than the destination. The technology is mature, but still fairly new. When you design your own, you know every part of it. You can repair, replace, or upgrade every part of it. You should understand why everything was built and the way it was, be it cost or function, in a way you can never get from a purchased model or kit. One thing to note, 3D printers are one of the best tools for prototyping. So building your own prototype printer is much easier if you already have a 3D printer. But I know if I already had one, I'd be way less interested in building one. So I went in without one. And then I used the one I built to upgrade itself. So, let me guide you through this journey. I don't recommend you take this exact same path, so I'm not going to be posting the plans, but I'll show you some of my pitfalls, the ideas that worked, and how I navigated to a working model that I'm very happy with. So I started out by drafting some plans, looking at what was out there and doing my own version. The basic outline is very similar to a Prusa, but I was focusing on sturdy, all metal. To save some cash and add some flexibility, I wanted to use a metal I could source locally from the Orange hardware store. So the frame I made is 1-inch aluminum square stock and L stock. I stuck with metric nuts and bolts, as most of the community uses metric sizes. This all worked out to be a good choice, and I'd recommend you do the same. Note, if you're in the US, some metric tools and parts, such as drill bits, are hard to find. But it's worth it to expand your fabrication capability and to support metric sizes, as the need for metric will come up again and again. Okay, so the first step was to build the box frame. Everything else hangs off this. I cut 4 2-inch long sections of 1-inch L stock, then 2 each of 10-inch long and 16.5-inch long square stock. The L stock was bolted to the sides and end pieces of the square stock, holding it together and also serving as the legs. To assemble, I taped the parts together tightly with blue masking tape and made sure it was all very square. Then I drilled the holes for the 4mm bolts. On the outside of the square stock, I then drilled the 4mm hole out to 10mm to give room for a screwdriver or a hex wrench. This is the basic process for all of the metal assembly. Line it up, tape it in place, mark, and drill. Also, before I forget, hit it with some Mother's aluminum polish. You might as well make it shiny. The Y table is going to be made of 2 pieces of plywood. The thick piece will be mounted to the rails with linear bearings that'll ride on 2 6mm rods that span the length of the unit. The rods are mounted into a U-joint, which is affixed to the front and the back of the printer base. A lot of care was taken to line this up all perfectly, but still, a slight offset was present that I've not yet fully resolved. The big flaw here is that there's no way to make fine adjustments to those Y rods. With auto bed leveling, the slight saddle shape that it causes is no longer a big issue. Holes are drilled in the base wood, and brass tubes are inserted to allow the adjustment screws to move. The top plywood is lined up and 4 long mount nuts are added. A motor bracket and a stepper is mounted on the back, and a small piece of L stock in the front with an idler pulley. The belt then runs under the table and is affixed at its ends near the center. With springs and adjustment bolts in place, the glass plate is set on top and the printer bed is complete. 2-inch flat stock was cut and drilled and mounted to both sides of the top center of the frame base to serve as the Z-axis motor mounts and rails. This worked great, however, it would have been better if the guide rails had been on the inside. The vertical portion consisted of 4 legs that mount to the base and an H-shaped top scaffold that connects them. The center of the scaffold sticks out to line up with the Z-rail holes. and the 6mm rods that'll act as the rails fit through the holes and are held tight with coupling adapters. One note on this: the standard Prusa has 2 legs behind the carriage. I thought 4 legs would be more stable, and it is, but having the legs in front of the carriage limits the width that you can attach there. I had to get creative to fit the cooling fan and the leveling sensor later. It would have been better if the front legs were 4 or 5 inches further forward. The Z carriages were cut from Delrin, then 2 linear bearings were mounted onto each. The X stepper mounts on the right carriage and an idler pulley on the left. On the inside edge, an additional strip is mounted with a 6mm hole drilled into the top and bottom of each carriage. This is where the X carriage rails will mount. On the left side, a section of 2-inch flat stock is cut and fitted with angle brackets made of L-stock. This will provide additional stability and serve as the spool holder. Threaded rods are coupled to each Z-axis stepper motor and threaded through a nut that's epoxied to each Z-axis carriage. The Bowden extruder is mounted to the top left, and finally, the power supply and electronics enclosure are mounted on the right back of the printer. The frame is now complete, and it's very sturdy. The X carriage was next. The first issue to tackle was how to mount the hot end. I already knew I was going to use a 2-inch square of Delrin with wheels as the mount, but actually attaching the hot end was more of an issue. I finally decided that the best way would be to whittle out a clamp made out of the Delrin and then mount that to a piece of L-bracket that bolted onto the carriage. This worked great, but the carriage itself proved to be problematic. The bearing wheels on 6mm rods was not a good arrangement, as there's too much play in the bearings. It worked okay at first, but later I switched to linear bearings. For lights, I added another piece of L-stock to the top front, and inside I mounted 3 3-watt LEDs in a small LED driver that I had. I left room for the WS2812 RGB LEDs that I planned to add later. End stops were added to the front and back, using some small cuts of wood so that they would hit and be activated by the bottom of the table. This would be the maximum and minimum Y. The Min and Max X end stops mount to the Z carriages on each side, bolted directly onto the Delrin mounts. A small bolt is added on each side of the X carriage to engage them and allow adjustment. The Z minimum end stop is mounted to the base of the right side, and a bolt is added to the bottom of the Z carriage for adjustable engagement. The 250-watt 12-volt supply has already been mounted to the frame, but I still need a power cord, and I want an on-off switch, along with some extra switches for lights, fans, etc. This is where already having a printer would have been really useful. Instead, I formed a switch box out of aluminum sheet metal. Inside this, I mounted the master power switch and a cord adapter, 3 indicator LEDs, and 3 switches. All of my cabling was made to use connectors, so it could be more easily repaired and replaced. So I soldered up a connector board for the switches, with resistors to power the indicator LEDs when the switch was on. Line current goes directly to the power supply from the power switch. 12 volt comes from the supply to my board, and then lights the hot end fan connected to the board. The Arduino Mega, ramps controller and stepper drivers, and Raspberry Pi Zero are mounted into the electronics enclosure. I also mount a small 5-volt buck regulator to power the Pi Zero and the 5-volt cooling fan for the enclosure. 2 voltage displays are added so I can validate that 12-volt and 5-volt supplies are good, and the 12-volt lines are connected up to the ramps board. Finally, all the lines for the steppers, end stops, and hot end are connected up to the ramps board, and the wiring's done. For software, I installed the latest version of Marlin on the Arduino Mega. I tried to use the Arduino UI, but I had many issues. In the end, I had to use Platform IO and VS Code. This was for the best. I think it's a better development platform, and it's not as complex as it seemed at first. The instructions on the Marlin website are excellent, so I won't go into it here. Then I flashed a microSD with Octopi for the Pi Zero. Again, base install following directions on the Octopi website. One thing of note, the Pi Zero works, but it's not very good. I later replaced it with a Pi 4, and I saw a noticeable print speed and quality increase. The final steps, perhaps a forever ongoing step, is adjusting settings and tuning. For this system, it was a bit more of a challenge, as I had to determine all the settings myself. No guides. There's some calculators to help figure out the number of steps, the driver voltage, etc., but there's still a lot of trial and error. But it's not all that bad. I may have had all my stepper directions inverted at first, but it was pretty easy to figure out and fix. Within 2 days of the first power-up, I was getting successful prints. Then, the next few months were increasing the print quality. but that's for another video. A few thoughts if I was to do this again. Other than the details I've already mentioned, spend a bit extra for 8mm or larger rods and bearings. There's a bit of flex in those 6mm rods. Second, go bigger. I was afraid that bigger would be less stable and cause issues, but particularly the Z-axis could have been 50% larger with no issue. Third, give the X-axis lots of room. I did mention this before, but there are so many neat add-ons, fancy cooling fans, dual nozzle print heads, etc. Make sure there's room in front of the X carriage for it all. And last, get the best Z-axis screws you can budget. Don't skimp here. Those 6mm threaded rods I started out with worked, but they're always bent, and the Z-wobble took a lot of work to get rid of. That's it for now. If you enjoyed this and would like to see more, drop me a comment and like the video. There are many updates I've done since its initial build. And until next time, thanks for watching.